Okay, folks, common errors. Let's do a couple of practice problems. Check your understanding. Okay, these are great to do leading up to your quiz or unit test. This will really test you on do you know your laws of logs? So be careful here. Determine whether each of the following is true or false. Justify your answer. This one, log base 5 of the argument x plus 10 equals. Okay, so no, this is false, guys. False. Why? Okay. This is an improper use of the product law. So what you might be thinking is if I have log base 5 of 10x, that equals log base 5 of x plus log base 5 of 10. That is the proper application of product law. So this is false. Okay. Letter B. Log base 2 of 18 divided by log base 2 of 9 equals log base 2 of 2. Folks, this this is false. Why? False. Well, it's like you're trying to do. This is an improper. Um, this is an improper application or use of the change of base identity. Okay, if I'm doing this correctly, the change of base identity says this, right? If I combine the logs, remember this number 9 becomes your base, and then this number 18 is your new argument when you are doing the change of base identity. So it should be log base 9 of 18. Okay. This is the correct way to apply the law. Apply the change of base identity. Okay. Letter C. 4 raised to the exponent log base 4 of y equals y. Oh, one of these. Okay. True or not? Well, let's see. You could convert it to log form and check, or take the logarithm of both sides. Let's do it both ways. So this is true, and we'll prove why. So here we go. Okay, so first let's do let's convert to log form. Okay, so I take the log, okay, and then the base of the exponent, which is 4, becomes the new base, becomes the base of the logarithm, and then the argument, okay, is the argument from the exponential expression or the equation, which is y, and that equals the exponent. This is the classic way of how we convert to logarithmic form, and this, folks, is true all day. Log base 4 of y equals log base 4 of y. Okay, so that is true. Or let's think of this. Let's take the logarithm of both sides. So if I have 4 to the log base 4 of y equals y, okay, let's take the log of both sides. So I'm going to take the log, not just the log. Let's take the log, yeah, just the log of both sides, common log. Okay, log of both sides. Okay, let me just be proper with how I'm writing this. I'm just going to start a new line here, so it's not super confusing. So if I take the log of 4 log base 4 of y equals log of y. So we're just taking the common log. I can bring this down as a coefficient with my power law. Oops. And I'm left with this expression. Okay. Oops. Let me write that properly. That's log of y, folks. Okay. If I divide by log of 4, so let me just bring this up here. Log base 4. Hang on, folks. Log base 4 of y equals log of y divided by log of 4. This is true because this is the change of base identity. Change of base identity. Okay, so this is true. Either way, it's true. Two ways to do it. Okay, log base c of 1 equals 0. This is true because if I convert to an exponential expression, I have c to the 0 equals 1. And this is true. I'll give you a caveat, provided that, I'll pause here, c, what's the stipulation or what's the restriction on c? C must be greater than 0. Remember, because 0 to the 0 is not equal to 1, right? So this is true provided that c is greater than or equal to 0. Okay? Letter E. Log base c of x to the y squared equals 2 times log base c of xy. This is false. This is super tempting, right? Let's be careful here. If I rewrite this, folks, right? This exponent 2, it is attached to y, not xy. Okay, so up here, so think about this. I'll write this nice and big. If I do this, this does not equal this, folks. Be careful. For obvious reasons, right? I have brackets here. So be super careful when we're thinking about this, okay? So I don't have brackets. So what should this look like? So this is false, right? What should this look like? If I do this correctly, I can split it up using the product law, like that. And this is how it looks when I write it in single logarithms in simplest form, okay? That's what happens to the 2 here. Okay. Okay, number 2, a student is solving the logarithmic equation log of x in brackets squared minus log of x cubed equals 0. Her work is shown below. There's an error in her solution because x equals 10 does not satisfy the original equation. Identify her error and provide a correct solution in the space beside. Okay. Okay, let's see. Let a equals log of x. Okay. Okay, so this substitution right here first I'll say this is a correct substitution. Okay, that's number 1. Number 2, I'll be right back. Just give me a sec. All right, folks. That's a correct substitution, right? We said let a equals log of x, and then that's what we literally did is we made a substitution, and we said that's a squared. Minus, well, we said a cubed. So let me make this statement. Log of x cubed does not equal log of x cubed. Okay, let me just write it this way without brackets for effect here. So, sorry, like this. Okay, that is not true, right? Because the brackets tell you a different story compared to the left side, which doesn't have brackets. So, this right here, this is an incorrect substitution. Okay, so be careful with that. Incorrect substitution. Okay. So it says there's an error in the substitution. Identify your error and provide a correct solution. Okay, so let's fix this. So fix. Let's fix this. So a squared we know is proper, right? So I'm going to do this. If I rewrite it like this, let me just start here. Log of x squared minus, let me be a bit neater here. Log of x squared minus, this part, let me apply the power law. So that's 3 log of x equals 0. Now, I'll do the same substitution. Let a equals the log of x. Okay, I'm going to do that substitution anyway. So that becomes, here it's going to become a squared minus 3a equals 0. That is the correct substitution, folks. And then let's solve for a and then unsubstitute and see what we get. So I'm going to factor out an a. So that's a minus 3. A times a minus 3 equals 0. Okay, and then when I solve this, a equals 0, a minus 3, a minus 3 equals 0, a equals 3. Okay, so let's unsubstitute. So remember this one here. So for this one, that's log of x equals 0. And how do I solve that? That is, let me solve it on this side. That's 10 to the 0 equals 10 to the 0 equals x. I'm going to convert it to an exponential expression, and then if I evaluate, that means 1 equals x. That's one of my solutions, which I'll check. Let me just go back. And then here, a equals 3, so that's log of x equals 3. So I'm going to unsubstitute, and that is, oops, that's 3, folks. Convert to an exponential expression, 10 to the third equals x, and I get 1,000 equals x. Okay, so if I check x equals 1,000, so let's check x equals 1. So that's log of 1 squared minus log of 1 cubed equals 0. So log of 1, that's 10 to the 0, so that is 0 squared minus log of 1 to the third, that is also 0, and that equals 0. 0 minus 0 equals 0. 0 equals 0. Check. Okay, that's good. Let me check the other one. I have log of 1,000 squared minus log of 1,000 cubed. And what does that equal? That's 3 squared. That's equal to 0. 3 squared minus 9 equals 0. 9 minus 9 equals 0. 0 equals 0. That is a check. Left side equals right side. Okay? Done with number 2. That's a challenging one. Tricky, tricky. Okay, number 3. A student is attempting to solve the equation 5 to the 4x minus 2 equals 3 to the 3x plus 2. The student's work is shown below. I love these kind of problems where we give you the work done and it's up to you to, like detective work, go back and figure out what happened, what went wrong here. Okay, so the student's work, oh, this is multiple choice. The student's work may contain one or more errors. In which line does the first error appear? Looks like we took the log of both sides, common log of both sides, which is a good method to do to solve an exponential equation. Okay, so let's take a look at this. Here's the problem I have, folks. When you use the power law, so right here, I'm going to line A. Okay, the answer is A. Line A is the problem. So incorrect application. So you cannot make up laws of logs. Okay, incorrect application of the power law. Why? Let's take a look. I should have brackets here because that 4x minus 2, those are exponents, folks, that come down and become coefficients when I apply the power law correctly. So what happened here is that since I didn't use brackets, everything else becomes an error as I go down, right? So this is the incorrect application of power law. I should have a set of brackets. Brackets, be careful. Brackets. Okay, so this is wrong, this is wrong. Okay, so line A is where the problem is. Okay, next page. Let's go. Number 4, identify the errors in the solution to the question below and determine the correct solution. Question, express the log of the entire argument here, a to the 2/3 divided by c to the 3rd, b to the 5th, as a sum and difference of logarithms. So we need to apply product and quotient law. Product and quotient laws properly. Okay. What did we do here? Okay. Looks like line 1 is quotient law. This is quotient law. Did we do it properly? Log of a to the 2/3 minus log of c to the 3rd, b to the 3rd. That is correct, folks. Okay. Yeah, here's the problem right here. Is we did not apply when if I throw a set of brackets here, right? This is the problem, right? I can see us using the power law. Sorry, I can see us using the product law, but this should be okay. Log of a to the 2/3 minus, let's use a set of brackets here. Just be careful. Log of c cubed plus log of b to the 5th. I need to use brackets, right? Because this minus sign gets distributed through. That's a different sign than this plus sign. Okay, so be careful when you're applying the product law here. Should be. So I'm going to put a little note here. Product law. And then beware of brackets. Okay, always a safe bet to use brackets. Okay, beware brackets. Okay, if I continue, first term here, I'm going to use power law. So 2/3 log of a. 2/3 log of a minus, before I distribute that negative sign and drop the brackets, I'm going to use power law inside the bracket. So 3 log of c plus 5 log of b. Okay, now let's distribute that -1 across the bracket. So minus 3 log of c minus 5 log of b. Okay, and okay, so this is the proper application. Okay, right here. So subtle difference here. Okay, that plus sign versus, sorry, that minus sign versus the plus sign. Okay, so there's your correct solution. Number 5, which of the following statements are true? Log of x divided by 2. So this x divided by 2, x over 2. Oh, come on. X divided by 2 is the entire argument. This one's pretty straightforward. All I'm doing from the left to the right side is I'm adding a set of brackets, right? So this is true. True. Okay. Letter B. Log of x plus 5 equals log of, in brackets, x plus 5. So this first term, no brackets. So if I rewrite this, so if I rewrite this, folks, this will become obvious when I show it to you this way, right? If I rewrite it as log of, let's do this. Since there are no brackets, I can rewrite it like this, 5 plus log of x. And this definitely does not equal log of x plus 5. Okay? So this is false. So be careful of brackets. Log of 3a equals log of 3a. Again, this is similar to letter A. 3a is the entire argument. So this is true. All I'm doing from left to right is just throwing in a set of brackets there. So that is true. Okay. Letter D. Log of x plus y equals log of x plus log of y. This cannot be simplified. Okay. I'm going to put a note here. Don't make up your own laws. Cannot make up your own laws, okay? This cannot be simplified. So what you're thinking is this. So first of all, let me just say this is false and false, okay? What you might be thinking for D is this. If I have log of x, y, that equals log of x plus log of y. This is the correct application of the product law. Okay, so be careful there. Letter E, log of 3 divided by 10. That's in the entire argument, folks. So this is letter E. Okay, that does not equal log of 3 divided by log of 10. I cannot just take that log as an operator. So it's an operation that we're doing on the fraction 3/10. I cannot just distribute it as if it's like we're like doing basic algebra. I can't do that, right? So this is false. What are we trying to do, right? So letter E, what are we trying to do? Log of 3 over 10. This is the proper application of the quotient law. That's log of 3 minus log of 10. So this is the proper application of quotient law. Okay, so letter E is false. Letter F, log of x in brackets squared equals log of x squared. No, this is false. Be careful, okay? I'll make a note here. Exponent is applied to log of x, not just the x, okay? So log of x squared, well, simple exponent laws, that's just log of x times log of x. Okay, while log of x squared, no brackets, that if I apply power law, it's 2 log of x. So two very different things. So letter F is false. Okay, are we done here? Well, I think so. Yeah, that's it. Here we go.